what is the relation between angular velocity and linear velocity? We know that the angular velocity is d theta dt and linear velocity is v. Okay, now we find the relation between d theta dt and v. How can we find the relation? We take, this is the initial line OX and this is pole and this is the path of the particle. Let it be at P at any time t. This is P r theta and this is the radial direction and this is the cross radial direction. Okay, and the velocity is given by the tangent. This is the tangent at P. Okay, and let this is the perpendicular. ON be the perpendicular from O to the tangent at P and let it be P, small p. This is the perpendicular distance from the pole to the tangent at P. And the velocity V act along the tangent always, and this is theta. And this is the angle between radius vector r and tangent. This is known as phi. This is the standard symbol of differential calculus. Then from the triangle ONP, this is height and this is hypotenuse. So we get P, this is equal to R sin phi. This is an important relation of differential calculus. Okay. Now we know from the relation of differential calculus as tan phi. This is equal to r d theta by dr. This is tan phi. Okay. And so we get sin phi by r d theta. This is cos phi by dr. And this is equal to sin square phi plus cos square phi by root under r d theta whole square plus dr whole square. And we know this relation is ds square. This is 1 by root under ds square. And what is ds? Let this is the initial point. This is known as A. And the length AP or the arc AP is S, and ds is a length at P. This is very small length of arc. Okay, so we get this is 1 by ds, and we get sin phi. This is r d theta by ds. Okay, sin phi, this is r d theta by ds by equating this and this ratio. Okay, now we already get the value of sin phi. What is the value of sin phi? This is p by r. So we put here p by r. This is equal to r d theta ds. Now we write this relation. This is p by r square and this is d theta by dt into dt by ds, right? And we get dt by ds means 1 by v. So we put the value of dt by ds. This is equal to 1 by v here. So v p by r square. This is d theta by dt. So we get the velocity v and d theta dt. This is the angular velocity. The relation between linear velocity v and the angular velocity d theta dt. d theta dt, this is equal to v into p by r square. Okay. Now put the value of p by r. This is sin phi. So we get d theta dt. This is equal to v by p into sin phi. And this is v sine phi by, sorry, this is not P, this is R, V sine phi by R. And what is V sine phi? This is V and this angle is phi. So this angle is also phi, this is opposite angle, and this is perpendicular direction of R, so this is pi by 2 minus phi. So the component of V along the perpendicular to the radius vector is given by V cos pi by 2 minus phi. So V sin phi, and we put here V sin phi in this position. So we get d theta dt, that is angular velocity, this is equal to the component of linear velocity along the perpendicular radius vector, component of velocity, component of linear velocity, perpendicular to the radius vector by R, that is R means OP, that is the length of the radius vector. Okay, so the angular velocity is equal to the component of linear velocity perpendicular to the radius vector by the length of the radius vector. This now, using the relation between angular velocity and linear velocity, we solve an important problem of particle dynamics. The problem is a particle describe a parabola with uniform speed so that its angular velocity about the focus at any point P varies inversely as Sp whole to the power 3 by 2. Okay. Now this is the initial line and this is the focus as whole, and this is the parabolic orbit. At any point P, this is the point at any time T, this is r theta, this is r, and we get that the relation between the angular velocity and linear velocity is given by d theta by dt. This is equal to Vp by r square. Know that the pedal equation of the given parabola, this is the parabola, pedal equation of the given parabola with focus S as whole is given by P square, this is equal to AR. Now we put the value of P here. This is P, this is equal to root under AR. So d theta dt, this is equal to V by r square into root under AR. So V into root A by r to the power 3 by 2. Okay. Now it is given that with uniform speed, so V is constant. Uniform speed means velocity is constant, and also A is constant. So V into root A is total a constant. So we take this value as K by R whole to the power 3 by 2. And what is R? R means Sp. So this is K by Sp whole to the power 3 by 2. So we say d theta dt proportional to 1 by Sp whole to the power 3 by 2. Okay, this is our proof varies inversely as Sp whole to the power 3 by 2. This is very important problem, but very easy problem with this relation.